Every engineer who's ever had to contain liquids or gases has known this moment. The time when a gasket fails. As our roads and floors emphasize, gaskets fail in their thousands, which means that thousands of replacement paper gaskets, fiber and cork gaskets have to be stored, lying idle, expanding inventories, tying up capital, just waiting for failure. And there's a lot to cause gasket failure. Differing thermal expansion rates can create hostile stresses causing fretting, which generates bolt loosening side loads and crushing loads, compressing and relaxing the gasket. Consequently, bolt clamp loads slacken. Fluctuating pressures and sudden surges can produce the same results, which attempt to force apart flanges and squeeze out the gasket. A gasket which may already be weakened by the attacks of corrosive material it has to contain. And a gasket's enemies aren't only from within. Impact, vibration and torsion generated during service also induce the stresses and micro-movements which cause gasket failure. The tremendous torque loads, for instance, placed on the transmission of Terex earth movers cause tiny flexing movements between the differential and the axle casing. Result, a leak. Terex engineers stopped that leak with one simple change. They threw away their gaskets and replaced them with a liquid, which simultaneously sealed and strengthened. In the Leicester laboratories of Rank Taylor Hobson, a TaliSurf 6 reveals the fundamental machining defect which enables strengthening and sealing to be combined. The operator of this computerized metrology instrument first selects a 2000 magnification, and then he actuates the sensor to show that a milled flange with a surface finish of 20 microns peak to valley really has numerous surface deviations. Even a setting of 1000 magnification reveals, in the three-dimensional view, as many peaks and valleys as the Alps. A gasket compressed into these surface irregularities will certainly block leak paths through those valleys. But it can do nothing to stop leaks caused by movement between flanges. The Loctite liquid sealant, however, can do both jobs, and has done so on all Terex wheeled earth movers for the past 8 years. Instead of sealing by compressing a non-structural malleable material, a Loctite anaerobic sealant works by flowing into the irregularities of both mating faces as the joint is assembled. Leak paths are sealed as the sealant quickly cures into a tough plastic which forms a definite structural link between the flanges. And note the metal-to-metal contact of the flanges. There is nothing between them to shrink, abrade or relax, so clamp loading is constant. The separate parts become one rigid unit with greater torque transmitting capability. To companies such as Jaguar Cars, aiming for clean, dry machines requiring little maintenance, the advantages of using formed-in-place gaskets instead of pre-cut gaskets have proved irresistible. To employ them on production lines, however, demands automated methods of application. For example, fitting a Loctite gasket to the camshaft carrier of V12 engines only needs the push of a button. The nozzle of this XY coordinate unit follows a pre-programmed path with a constant speed control, ensuring an even bead of sealant. To form gaskets on smaller parts, Jaguar screen print gaskets. The method deposits just the right amount of sealant to give main bearing caps a perfectly formed and accurately positioned gasket. This method is also used to simultaneously print gaskets for 4 water cover plates. Because the anaerobic Loctite sealant cannot cure until the parts are assembled and air is excluded, this mass printing of gaskets doesn't result in waste. Left in the open, the gasket remains fluid, yet seals instantly when parts are assembled. In the Austin Rover factory in Longbridge, the gasket printing process is completely automatic. All the operator has to do is place components into an applicator. Closing the door starts the process. Giving cam carriers for S-series engines a gasket containing only 1/5 of the sealant which would be applied were it done by hand. And you don't have to look far to see the results of that automatic production. Loctite printed gaskets ensure clean, dry engines in the Rover 200, the Montego and the Maestro. In the Peterborough plant of Perkins Engines, you can see another automatic application of Loctite gaskets. This time using an advancing head dispenser and rotary table to gasket water pumps for diesel engines. Where the weight and bulk of parts make screen printing or tracing impractical, gaskets can be rolled into place. At the Doncaster plant of J.I. Case, this method is used extensively during the assembly of tractors. Air pressure, triggered by the user, squeezes sealant onto a roller to form a thin, uniform gasket. In service, the gasket must both seal and strengthen the highly stressed joint between clutch housing and mainframe. The same fast method is used throughout mainframe assembly. Liquid gaskets from the roller now also seal axle housing and hydraulic cover plates. But this change was only made after several months of field trials and rig tests had proved that Loctite liquid gaskets were superior to cork. J.I. Case also used the same versatile sealant to seal the external shells of oil seals and to strengthen their retention. And Case even used the same product to secure and seal bolts, preventing leakage past threads tapped into gearbox casings. But this versatility was not the reason why J.I. Case changed from pre-cut cork gaskets to Loctite formed-in-place gaskets in November 1985. Conventional gaskets couldn't endure the loads imposed upon them as the tractor twisted and turned, pushed and hauled. J.I. Case now use Loctite gaskets for the same reason as the earth movers Terex and tank makers Alvis, to gain metal-to-metal seals which add structural strength and increase torque transmission. No traditional gasket can give these advantages, which is why they're no longer used in the final drive of Alvis armoured vehicles produced in Coventry. Development Manager John Radford.
When this project was originally designed, the design incorporated the standard paper gasket seal. Following trials and experience in service, we experienced oil leakages from the joint between the annulus and the stub axle due to this gasket fretting. We introduced Loctite gasket seal, and after extensive trials by the British Army and ourselves, this overcame the problem of leakage and was eventually introduced into service.
An MOD-approved Loctite sealant is now manually applied by a simple syringe that is both container and applicator. With it, a liquid gasket can be applied quickly and cleanly to prevent the micro-movements which caused the fretting between the stub axle, annulus and sunwheel housing. Containing 65 millilitres of Loctite sealant, the syringe provides a continuous bead that can replace 6 meters of conventional paper, fibre or thin cork gaskets. Incidentally, this handy syringe, which is ideal for quickly forming complex gaskets in confined spaces, is the same tool which is widely used for maintenance and repair in the field. Mechanics in several armies now use it to restore their armoured vehicles to fighting trim. There's less to carry, there's less to store. When in service, Loctite seals an OMD 80 oil which can reach a temperature of 150 degrees centigrade, particularly when an Alvis Scorpion is in a hurry. With such a parade of tanks, trucks and tractors, it would be easy to make the mistake of thinking that Loctite gaskets are only for the mobile, a mistake which R.B. Bolton, the mining engineers in Consett, County Durham, are thankful they never made. Here, the labour of handcrafted gaskets has been replaced by the leisure of liquid gaskets. Cover plates made from unmachined stock are now sealed with a Loctite sealant to flanges that have been roughly abraded with a hand grinder to remove weld spatter, a change which has helped reduce the time of manufacture for a 350-gallon hydraulic tank from 50 hours to just 18. Similar savings have been made during the building of Bolton Dynatrac chainless haulage traction units used to drive coal cutting machines. The lubricants in the heavy-duty three-stage drop-shaft traction unit range from an EP90 to a power gear oil. But despite this variation, only one general-purpose sealant is used throughout construction. Simply applied and accurately positioned by a standard handgun, this single sealant will form a gasket that never strays out of place during assembly. The contact of mating flanges automatically spreads the sealant into a wide, leak-stopping gasket. And after assembly, any excess is simply wiped away without the need for solvents. This massive example of Loctite sealing power supplies a torque of 30 tons to the drive sprocket of a Bolton Dynatrac. That's the force needed to propel this 40-ton mechanical cutter along the coal face. Day after day, at speeds of up to 30 feet per minute, the cutter hews out 1,000 tons of coal every hour. But at the final proving ground at the coal face, you'll find many examples of Loctite gaskets. At Westow Colliery, 10 kilometres out under the North Sea, for instance, you'll see Bolton's hydraulic supply tanks. And the product Bolton service engineers always take with them. You'll also see Dosco tunnelling machines, such as this Mark IIA roadheader. These machines are overhauled at the Allerton Bywater National Workshops in the northern region of British Coal. It's here that the gearboxes for road headers and dint headers are totally rebuilt. Note that the gearbox halves are split at the bearing centre line. Because the Loctite sealant ensures metal-to-metal contact between the flanges, there's no shimming effect. Consequently, the clamp load on the bearings can be precisely calculated and maintained. The internal filter gave British Coal another incentive to change to Loctite. Pre-dispatch trials showed that excess from previous air-drying sealants squeezed into the gearbox blocked the filter. But excess from an anaerobic product, even the non-drip version used by British Coal, can always be wiped away from the outside and flushed away from the inside, a fact proved by tests at Allerton Bywater. But the ultimate test for machines rebuilt at this North Yorkshire workshop is provided deep underground. As you've seen, there are many uses for a Loctite gasket, and many different ways of applying it. But there are always two questions asked by everyone considering this product. First, if it gives such a strong seal, how do you dismantle the joint? For the answer, let's go back to the R.B. Bolton factory at Consett. Here, their hydraulic supply tanks also eventually return, after several years of continuous service in British coal mines. During reconditioning, the tanks, scarred by their service in the mines, will be completely stripped and all covers removed, proving in the process that normal tools and ordinary methods are all that are needed to break the seal. The second question always asked is, how are the original Loctite liquid gaskets replaced during routine maintenance? You'll find the answer wherever engineers overhaul, repair or service vehicles, plant and machinery. After the original gasket is scraped away or dissolved by a Loctite gasket remover, a new liquid gasket is simply squeezed into place. Because squeeze bottles, tubes and cartridges of Loctite liquid gaskets identical to the product used during the original manufacture are available throughout the world. With one of these in his toolbox, any engineer, anywhere, has the answer to the question, to leak or not to leak.